Welcome to the DIY Honda Garage channel. In this presentation, we will explore the diagnostic trouble codes DTC P0973 and P0974, which relate to the shift solenoid valve in the Honda Pilot, manufactured between 2016 and 2022. DTC P0973 signifies a low input from the shift solenoid valve A, while DTC P0974 indicates a high input from the same component. The transmission of this vehicle relies heavily on the shift solenoid valve as it controls the flow of transmission fluid, facilitating gear shifts seamlessly. Located within the transmission assembly, these solenoids play a critical role in the overall performance and efficiency of the transmission system. If these codes appear, it is crucial to conduct a thorough diagnostic assessment to pinpoint the electrical circuit problem causing the issue, as they cannot be attributed to mechanical problems within the transmission itself. Let's dive into the detailed error description to better understand the implications of these DTCs. The shift solenoid valve, A, is primarily responsible for regulating the pressure and flow of transmission fluid, which directly impacts the vehicle's shifting performance. Typically located within the transmission assembly, this solenoid works closely with other components to ensure that the appropriate amount of fluid is sent to the necessary clutches and bands during gear changes. Codes P0973 and P0974 indicate issues with the electrical signals sent to this solenoid. DTC P0973 points to a low input signal, suggesting that the solenoid is either receiving insufficient voltage or exhibiting a poor connection. Conversely, DTC P0974 reflects a high input signal, potentially indicating a short circuit or other wiring fault, impacting the solenoid's performance. Since these codes are electrical by nature, they require careful investigation of the circuits and connectors directly associated with the shift solenoid. The primary cause of DTC P0973 and P0974 is rooted in electrical circuit problems, not mechanical failures within the transmission. A malfunctioning shift solenoid valve itself can lead to low or high input signals, suggesting it may need replacement. Poor connections, such as loose terminals or corroded wires between the sensor unit and the transmission control module, TCM, can also trigger these DTCs. It's essential to establish a solid electrical connection to ensure that the solenoid receives accurate voltage readings. Additionally, intermittent failure can occur if the vehicle operates correctly at one moment, but the codes flag up at another, which may complicate the diagnosis. Ensuring connectors and wiring are intact and functional is crucial in rectifying this issue. When DTC P0973 or P0974 is present, drivers may experience a variety of symptoms that indicate problems with the vehicle's transmission performance. Firstly, noticeable transmission shifting issues are common, as the shift solenoid plays a crucial role in enabling smooth gear changes. This can lead to jerking motions during acceleration or a delay in shifting between gears. Often, the vehicle's warning light may illuminate on the dashboard, alerting the driver to a system fault that requires attention. Additionally, poor acceleration may occur, hindering the vehicle's ability to respond effectively when pressing the accelerator. These symptoms can result in an uncomfortable driving experience and potentially lead to further complications if left unaddressed. The first step in troubleshooting DTC P0973 and DTC P0974 involves verifying the existence of the trouble codes using a Honda Diagnostic System (HDS) tool. Begin by turning the ignition key to the on position without starting the engine. Once the vehicle is in this mode, proceed to clear any existing DTCs present in the system using the HDS. Following this, turn the vehicle off and then, after a moment, return it to the on position. Allow the vehicle to sit in this mode for several seconds to enable the system to reset. This step is essential to confirm whether the DTCs reoccur, as doing so will help to differentiate between an intermittent issue and a persistent error originating from the electrical system. Once the wait period is over, check for any pending or confirmed DTCs using the HDS diagnostic tool to determine the next steps. In this step, you will perform an open wire check by first turning the vehicle's ignition to the off or lock mode. It's critical to ensure that the engine and electrical system are off during this procedure to prevent any accidental circuits from activating. Next, disconnect the TCM sub-harness 26P connector and the TCM 58P connector to directly access the wiring without interference from other components. With the connectors removed, check for continuity between specific test points. Specifically, you'll want to establish continuity between test point 1 of the TCM sub-harness connector, number 1 and number 2, and test point 2 of the TCM 58P connector, number 3 and number 38. This involves using a multimeter set to the continuity setting to verify if there are any breaks in the wire. If continuity is present, it indicates that the SHA, shift assist, and VBSOL, valve body solenoid, wires are intact and not open in the circuit. However, if there is no continuity, this suggests that a repair is needed to fix an open circuit between the sensor unit and the TCM. The third troubleshooting step is to check for any shorted wires within the SHA and VBSOL circuits. This step involves checking continuity between specific terminals on the TCM 58P connector and the vehicle's body ground, while keeping the vehicle in the off or lock mode. Disconnect the TCM sub-harness 26P connector and the TCM 58P connector to prevent any interference during the testing. Using the multimeter, test continuity between the female terminals of the TCM 58P connector, number 3 and number 38, and the body ground. If continuity is detected, this indicates a short to ground in one or both of the wires leading to the solenoid valve. This issue requires immediate repair to ensure the integrity of the circuit is restored. On the other hand, if no continuity is found, it implies that the wires are functioning correctly, and further troubleshooting may entail the replacement of the hydraulic control unit as the source of the DTC codes. After all necessary repairs have been made in response to the DTC P0973 and P0974 codes, it is crucial to verify the effectiveness of the repairs. Begin this process by reconnecting the TCM connectors and then using the Honda Diagnostic System HDS to clear any DTCs present in the system. This step ensures that any previous errors are removed and allows the system to reset for fresh diagnostics. After clearing the DTCs, conduct a test drive of the vehicle under normal operating conditions to assess its performance in real-world scenarios. Pay attention to how the transmission shifts and whether any warning lights illuminate. Verifying these repairs is essential to confirm that the earlier issues have been addressed successfully, allowing for reliable performance moving forward. Implementing preventive maintenance is essential to avoid future occurrences of DTC P0973 and P0974. Regularly inspecting electrical wiring associated with the shift solenoid valves can help identify any wear, corrosion, or loose connections before they escalate into more significant problems. It's also critical to ensure that all connector terminals are clean and securely fastened, as poor electrical connections are a common cause of signal issues. Complementing these checks, maintaining appropriate transmission fluid levels and quality is crucial to the transmission's overall functionality. Regular fluid changes and quality checks can help protect the solenoid valves from malfunction due to inadequate lubrication. By performing these preventive steps, vehicle performance can be enhanced, reducing the likelihood of encountering similar DTC codes in the future. To summarize, the diagnostic trouble codes P0973 and P0974 point to electrical issues concerning the shift solenoid valve A in the Honda Pilot 2016 to 2022 models. Namely, these faults cannot be attributed to mechanical problems within the transmission, making it vital to address wiring and connector issues first. A systematic troubleshooting process is necessary to diagnose the exact failure, involving checking for open circuits, continuity tests, and looking for shorts to ground. Understanding that these issues are primarily electrical allows technicians to effectively narrow down potential root causes and perform targeted repairs. Additionally, adopting preventive maintenance measures can significantly diminish the chance of these DTC codes appearing in the future, ensuring a smoother and more reliable driving experience. Please like and subscribe to the channel. See you next time.